Welcome back to We Dared Chemistry. In this lecture, we will spend our brain learning about Bohr's hydrogen atom model, so join us whether you are a student or a curious mind. Hydrogen model. Niels Bohr, 1913, was the first to explain quantitatively the general features of the structure of hydrogen atom and its spectrum. He used Planck's concept of quantization of energy. Bohr's postulates. The electron in the hydrogen atom can move around the nucleus in a circular path of fixed radius and energy. These paths are called orbits, stationary states, or allowed energy states. These orbits are arranged concentrically around the nucleus. The energy of an electron in the orbit does not change with time. However, the electron will move from a lower stationary state to a higher stationary state when required amount of energy is absorbed by the electron or energy is emitted when electron moves from higher stationary state to lower stationary state. The energy change does not take place in a continuous manner. The frequency of radiation absorbed or emitted when transition occurs between two stationary states that differ in energy by delta E is given by delta E equals E2 E1. The frequency of the radiation absorbed or emitted during the transition differs in energy. Delta E equals E2 E1. Delta E can also be written as Planck's constant into frequency. H into nu equals E2 E1. Frequency equals E2 E1 divided by H. The angular momentum of an electron is quantized. In a given stationary state, it can be expressed as an equation. Mass into velocity into radius of orbit equals n multiplied by h upon 2 pi, where n equals 1, 2, 3. Angular momentum of electron may be equals h/2 pi, 2h/2 pi, which proves that it quantized. Radiation is emitted or absorbed only when transition of electron takes place from one quantized value of angular momentum to another. This was the Bohr hydrogen model. Thank you for your attention. Keep studying with We Dared Chemistry.